in the final, you have to be able to go ahead and do 4 or 5 problems from each unit you've done. Now, with that in mind, 4 or 5 problems from each unit. So the unit I just returned, which is the formula unit, you'll want to think about which 4 problems out of those might be appropriate for the final. And I can tell you right now, the last problem on that test, where you have some irregular shape, would be an appropriate problem for the final. So let me show you a typical shape. This is the one we did, so people at home don't have the luxury of knowing what we did, because they didn't take this, and just if you're watching this vicariously and enjoying not taking tests and such, here's what it looks like. This was the shape. And some things have been filled in here. This was 36 square inches or square feet in that square. The triangle had 24 square feet. And then, of course, I don't know if that's a correct value. Yes, it is. On the semicircle at the bottom, that was 14.13, I believe, square feet. And then the idea was that you added all that together to get the area inside that shape, which I consider a somewhat irregular shaped object. We come off there for a moment, Debbie. I'm getting some kind of keystoning. Let's see if I can flatten that out. This is a little better look at that. So you have a square on your left, a half circle on the bottom, and a right triangle on the right. And those dashed lines are just to help you separate out a total of 3 regions. So the problem was to find the area and the perimeter of that figure. So if I slide this up, just if you want to reference, because I didn't write this in, here are the 2 answers for that. The area was 74.13, and maybe I can drop that down just a little bit, Debbie. So let's come off for a moment and see if I can get that so it's more readable. Here are your 2 numbers. So you have 74.13, and you had a 39.42. Now the area is square feet, the perimeter is feet. Now my point is, you're going to have a problem like that in the final. That I'll promise. Now you're going to have 3 or 4 other problems, so maybe the area of a circle, the volume of a cylinder, the volume of a sphere, the perimeter of a triangle. You can't just say at this point that test is done and I don't have to worry about it. You're going to come back and see it again. And what about the counting test? And we haven't done much in the last week. I spent the week before giving you a few problems in counting each time. But the problems in counting will also be on the final, and you'll have 4 or 5 of those. So here's my suggestion to you. Since I just returned a test on formulas, I would get 3 by 5 cards and maybe select 5 problems, half the problems from this test. Write them down on the card, front side the problem, back side the answer. And then, in a week or 2, go through the deck and see if you can do the problems. Do the same thing with the counting test. Do the same thing with the work we're doing on dimensional analysis. So by the end of this next week, when we start thinking about a test on how much, you should be sitting there with 15 cards that you can go ahead, shuffle the cards, take out a problem at random, try to get the solution, check your answer, and see if you've got it. Now, you don't have to use just the problems on the test. You might pick a different problem, one of them that we did in the unit. But if you will select different problems, then I've got 3 of you up here to my right side. So Chris could give Elvin his deck of cards. Elvin can give Adrian his deck of cards, and we can swap them. And you then have 45 cards for the 3 of you that you can go through and practice. By the time we have done all the units in the book, you're either going to have 30 or 35 cards apiece. So if you have 3 of you, that's 105 problems you can go through in preparation for the final. The final will be 400 points out of 1,000 for the second half. 400 out of 1,000. That's a rather important percent. Okay? So 40% of your grade in the Orange Book will be on the final. That's half your semester grade. So we are working on dimensional analysis. I put a problem behind me on the board here that we're going to look at, and it's just one I want to reference because I have some other problems I want to do. But Debbie, as we cut to that problem, this is a problem from the DMV. And here's how the problem was stated. If you're going 60 miles per hour, how many feet do you go in 1 second? And that was an actual DMV problem on a test, meaning Department of Motor Vehicles, in order to get a license. It's a how much problem. Now the question, why do they have this as a question on the DMV? What are they trying to get at? What is the biggest concern right now for people driving that's in the hot box as we come back? Stopping distance, but what are the distractions that we are dealing with? Okay, everything. More precisely, I think a lot of the interest right now is on the cell phone. Because if you are dialing on a cell phone, even if you have speed dial, what do you tend to do? Look away from the road for a moment. You hunt for the button you need for the speed dial, or I've seen some people watching the road like this with the cell phone in front of them. But if you are just sitting there and you have to punch in the numbers, let's say you lose 1 second. What happens in that 1 second? Well, if the driver in front of you goes into a panic stop, okay, then, and you haven't, you're 1 second, you're looking away, come back up, and suddenly you're there. Okay, you're on that person's bumper, and you haven't even begun to hit the brakes. That's the 1 second. Now, if we look at that and talk about what are the other distractions that we have? No. In the car while you're driving? Reading a book while they're driving?
Newspaper, paper, directions.
Okay.
Kids.
Kids. The one that comes to my mind, you got 3 kids in the back seat. You're driving down the freeway, and Junior has just hit Sissy on the head with a magazine, and they're now at each other. So you turn around, and in 1 or 2 seconds, you try to convince them that they should behave more appropriately. That's minimally what happens. I think my mom usually go, whop, and say, enough. That 1 second you turn around, and you are again on somebody's bumper. So the question, how many feet do you travel in just that 60 miles per hour? And by the way, over this last couple of days, I was going back through some newspapers that I hadn't read. With the schedule and grading papers at 4 and 5 a.m., oftentimes the papers I try to read don't get read. So that list includes typically, if I'm lucky, things like the Wall Street Journal, New York Times, San Francisco Chronicle, and Modesto Bee. Try to go through those in the morning before you finish your coffee, and it just doesn't work these days. So I was going through the papers the other day trying to scan them and see if there anything that I really wanted to read. So I went through about 20 different papers that haven't been read. And I came across a headline or subheadline that said the speed limit in some places is going up to what? 80. Now you can go, awesome. Okay, you can go on the freeway on I-5 in certain portions at 70 and be legal, right? Now I realize some people are doing then 80, and that's being polite. But if it goes to 80, what will some people do? 90. That's really surprising. So I'm going to change the problem I have on the board. Now the problem on the board was at 60 miles per hour, how many feet will you go in 1 second? Let's do it at 90 miles per hour. So if Adrian's wheeling around at 90 and he looks at his cell phone for 1 second, how many feet will he have gone? That's the question. So let's come back to this. Now the setup, and I'm going to do some erasing here. We're going to start with a 90 here, 90 miles per hour. And I fully realize that there are some big rigs that seem to be doing this now, which is frightening. if you're behind them or in front of them, either way. Now, the reason I say frightening, I used to, when I came to school here as a student, I was driving from Tracy, and it was foggy. And we went Highway 132 because you didn't have to go through Manteca that way, which didn't have a bypass at that time. And so you get in Highway 132 in two-wheel fog behind an 18-wheeler, and that 18-wheeler you hoped was high enough above the ground they could see over the fog. So if they were doing 90 and you're following them and your car only does 65 because it's an old car, that was frustrating to keep up with them. And if you couldn't see their tail lights, you were in deep trouble. And if you slowed down too far, what were you potentially at risk? Somebody will rear-end you. So you're sort of between the rock and the hard spot. You stay home. Okay, and then you don't get your classes. So anyway, where do we start? We start this, and let's just zing in a little bit tighter here, Debbie, just to look at the first part. Because we want to know feet at the end. That was the question. How many feet? And I know something that I'm going 90 miles an hour. Not me, Adrian. And so in this problem, I start with 5,280 feet in 1 mile. So the question, as I come off, which camera are you on at this point? 2. Okay, so we'll come back to 1. We have to know something about feet and miles. Now, depending on how much background you have, if you've ever been in Denver, that's Colorado. That's where the West is, really, as far as people in New York are concerned. You don't believe that? They think California is near Hawaii. And so the West ends at the Rockies, and so we're going to fall off into the ocean. That was the argument. I went to school back in Colorado for my doctorate. And so they just believe California was a lot of surfers who are going to be out near Hawaii. So let's look back at the table of equivalences on page 66.
So in doing this, we should really look at that.
Well, you're going to have to memorize this. That was my segue into this. We memorized formulas, and so this is the bit of subtlety lost. I want you to know all these.
I already told them.
So you told him, right? Okay, and Adrian didn't believe you. He was doing too much speed at 90 miles per hour. So he wouldn't concentration on the traffic. So here's the list. Notice the first one. 5,280 feet, 1 mile, and if you lived in Denver, you know that's mile high, and that's 5,280 feet, 1 mile. Now we're going to change this speed, but the notion here is that if you have miles here, what must be in your next fraction?
Wow.
Miles in the top. That's the chaining that went on. I call it chaining. I'll explain that in a moment. So you know that's in 1 hour. Now and we have an advantage that those of you watching at home don't know what comes next, and that's good. Those who are in class have that as information, so they are really at an advantage or a disadvantage. What must be in the next fraction on top? Hours. So as we just slide over, we won't zoom out, we'll just slide over. That means that I have to have hours up here. And I need to know that 1 hour is 60 minutes. Let's go back to our dimensional analysis table of equivalence. Yeah, you look at this list and you say, God, I have to know all those. Well, don't you know some of these? You know that 12 inches are in a foot and 3 feet are in a yard, and you know 60 seconds in 1 minute and 60 minutes in 1 hour. Many of those you know. And you should know that 16 ounces are in a pound. Maybe the ton is a little bit awkward for you, but there are only maybe 2 of those that are new. So it's not like saying you have a whole list to memorize, just a few new ones. So let's come back to this. I now have 1 hour, and the hour does what? Cancels with the hours, but then I introduce what? A new dimension. New dimensions, musical group, right? Okay, before your time. Okay, minutes down here, slide over, and I need what? Minutes in the top. Now I need to know what? Minutes and seconds. Back to my list. It's there. And then, of course, at the end I have what? 1 second. Slide over just a little bit. So all the dimensions cancel except we're just going to pan as we go along. Notice how the dimensions cancel until you get to what? Feet, the only thing left. Now I need to write what I have left, so let me erase this part because we're going to have different numbers here. So let's now write what's left. That sounds awkward, right? Write what's left, right? You are asleep this morning. It's Thursday, right? More rights and wrongs. Okay, so we have 5280 times Adrian's 90 times 1 times 1 times 1. You love those ones. And I'm going to make a long fraction bar. I'm not going to try to freehand it here. There's my fraction bar. And what do I have in the bottom? The 1, the 1, the 60, and the 1. And okay, well, hold on now. At this point, this is going to be in what? We have to have our units. So let's slide over, zoom out just a little bit for me, Debbie. And then over just a little. This is in feet. Okay? So I'll move off camera. That's what we have to do. Now, question. If you've got a calculator, you could do the whole numerator, just multiply all that together, multiply this together and divide. Or we can do what? Maybe come over here and say 60 and 90 have something in common, correct? So 10 goes into here 9, 10 goes into here 6, but then what can I see? 3 into here is 2, and into here is 3. Okay, take 10 into here is 6, and 10 into here is 528. Can I do more? Oh, you could do it differently, but just taking what? Okay, the 6 into the 528, and that goes how many times, Travis?
I just know it.
You don't know. You gave me the division. 6 into 528. What is it? 88? Okay, now what can you do? The 2 into the 88. You're going to give the same excuse this time. I just saw it. I don't need to know it. It's a 44, correct? Just giving Travis a bad time. So what's 3 times 44? 132, which happened to be the highway I was traveling. Okay, 132 feet. How many car lengths is that? How long is a small car? One of the ones that you get enough mileage you can afford to drive it.
About 8 feet long, 6 feet.
8? A car?
You lay down next to it and do about that. 6 feet.
You are driving a very small car. It's called, is that what they call a golf cart?
Datsun. No, just kidding. Datsun, B210.
Okay, the Zions and the Prius and the smaller Hondas, and what are we talking about lengthwise? Anybody? Maybe 15 feet? Something like that? Say it's 13 feet? I think they're a little bit longer than that. But it was 13 feet, about 10 car lengths. So if you're going to drive at this speed, and the person comes to a dead stop in that 1 second, you have 13 car lengths, no, 10 car lengths you have to be away to have a hope of stopping before you go under their bumper. If you're in that small a car and they've got a big car, you're sliding under the bumper. Okay? If you're following an 18-wheeler. Okay, DMV would like you to know that. Of course, the moral of the story is stay far enough back. Of course, if you do, what's going to happen if you stay 10 car lengths away? Okay, if you stay that far away, somebody's going to do what? Cut you off? Are you one? You have 10 car lengths away, somebody's going to fill in the space, right? And so you usually, if you don't want to keep just getting further back in line, and you have a NASCAR mentality, you know, the idea is nobody's getting in front of me. Then you have a space of about 1.5 car lengths. And then if there is a panic stop, you're under the bumper.
Doesn't DMV say stay at least 3 car lengths away?
The DMV says, I believe, for every 10 miles per hour, about 1 car length. And that was when the car lengths were about what? 20 feet? You've seen the caddies from 1960? Okay, they are about 20 feet long. So, yeah, they're nice boats, right? That's why they called them the Land Cruisers. Okay. Let's try a more interesting problem. This is one that I have a colleague or a friend who is a former student, and he's the person who helped set up the web pages for me. And right now he's working for one of the wineries up in Napa Valley. He's got a very nice job. However, he's tech support for the IBM iSeries, and that means he's on call a lot. And his days are 12 and 14-hour days and works the weekends. And it's fortunate he likes what he does, because otherwise it would be unforgiving. But he suffers the same problem I find I have, and that is we both get very little sleep. So if we get 4 hours of sleep, 5 hours of sleep, that's a pretty good night. That's good. 5 hours is about right. And we like to read. And our schedules are busy enough that if you're wanting to read a book, not the newspapers, you find that you do it just before you go to sleep. Now we're finding an occupational hazard here. 2 pages and you fall asleep. And Sarah has to take the book out from under my head because I've fallen asleep in the book, and I'll find it in the floor at night. It's embarrassing. And you've read 2 pages. So if you want to read a long book, how many weeks or how many months, let's maybe do months, how many months to read a book that's 1,000 pages? And that's not necessarily, I mean, some novels are up around 1,000 pages. So you start reading the book and you're reading 2 pages per night or per day. How many months to get through the book? You understand my question? Yeah. So you're sleepy enough, 2 pages, and it's lights out, not the light on the table, it's your lights are out. I feel like one of those, and I don't know if they still have them. When my daughter was young, got her a doll, and you put the doll down, the eyes close, and that's it. I'm about in the same position. Put me in a horizontal position, the lights go out. So 2 pages. So that's what we're going to look at. 2 pages a day. How many months to read 1,000 pages? Okay, so that's what we're going to do. So as you look at these equivalences, these are the ones I want you to focus on now. We're on page 66. Think of what we're going to need here for the problem I just explained to you. Okay, the question, how do you get it started and how much? The answer is always more obvious than you thought. Now, I'm asking how many months, correct? That was my question. How many months? See, I read papers a lot, so I do newspaper columns as I write. How many months? Well, that's what I wanted at the end, so that's where I start. It's that simple. Ask what you want at the end. That must be in the numerator of your first fraction. So it is going to be 1 month.
4 weeks.
Wait a minute. 1 month. Now the question, I have a couple ways I can do this, because coming back to the list, I have 12 months in a year. I have 52 weeks in a year. I have 30 days in 1 month. I have 4 weeks in 1 month. There are a lot of equivalences there that have months, correct? Months and weeks, months and days, months and years. Now think of the problem as I stated it. Let's come back to here. I said 2 pages per day. So if I want to know how many months for what? 1,000 pages. Now I have choices here, correct? And depending on the choice, I'm going to get a different answer. Because how long is a month? Well, let's come back to the list. I've given you the banker's month. Now you realize that not every month has 30 days. February, for example, has 28, except when it has 29. The month we're in has 31. So if I say 30 days, that's a banker's month, which means 360 days for the year. But if I say weeks, coming back to my list, each week has what? 7 days. So if I take 4 weeks for a month, that's a 28-day month. So how I set this up is going to give me a different answer each time. Now, given the way it is, it's probably most efficient to do what? 30 days. But let's just have some fun and do it with weeks. You can't remember how many days are in a month, so you say instead, 1 month is 4 weeks. If I do it that way, then what must go in the next fraction in the top of it? I'm going to have, no, not necessarily 4 weeks, but I have to have what? Weeks in this if I'm going to do what? Cancel what's here. And that's coming back to Teresa's question. That's okay. Coming back. But coming back to Teresa's question, we should just show her. At this point, it is, how do I start? Well, you want the answer as the numerator. Now, the denominator is going to depend on what equivalences you have. I chose weeks here. I could have chosen days. But by choosing weeks, I know that this is going to cancel. And now, since I have days involved, I might want to say that 1 week is what? 7 days. And that tells me what about the next fraction? It has to be days. Okay, so I have days here, so that they will cancel, agreed? And now, remember, I'm with 2 pages per day, so couldn't I go ahead and use this to say 1 day is, no, 2 pages. Otherwise, use as much information from the problem as I can, because I'm going to multiply by what? 1,000 pages. Because the pages now will what? Cancel. And I'll just walk off camera for a moment. Now, what is left in my answer? A month. That's the key. That's what I wanted at the end. So this question was, how many months? And I have exactly that left here. So I'm going to go ahead and now write out the numbers I have. Now, interestingly, I have a bunch of ones up here, right? 1, 1, 1, and then 1,000. So 1, 1, 1 times 1,000 over what? 4 times 7, bless you, times 2 times 1. That 7 is not good. Why? We aren't going to have much luck canceling a 7 with anything other than a 14, 28, and so on. But we also get weird decimals. Remember the 7th? 0.14285714285 forever? You don't remember that. Okay, that's months now. Now, we can do some simplification here, correct? We can go ahead and say 2 is into here. Or I could say 2 times 4 is 8. That leaves me a 7, and 8 into here is 125. So I have 125 over 7, and what does that come out as? We're getting what now? 7 into 17. I want the answer. So you're saying 17.85 months? So 17.85 months. Let me just come. We'll just leave that up there. How long is that? It's a year and 5 months. It's nearly 18 months, correct? So I could have said how many years? Okay.
So you don't do anything with the 8?
I did. 8 goes into 1,125. 2 times 4 was 8, and 8 went into 1,125. My point is, this is 18 months to read this book. Okay, now, if you're reading a book, it's a year and a half. My problem is trying to remember what somebody did in the first chapter a year and a half later when you get to the end. So what do you have to do? Reread it, because you've forgotten what happened at the beginning. The moral of the story, read short books. Okay, so at Starbucks this weekend, I found a book that measures about 3/8 of an inch thick with small pages. I can read now 8 pages a night. And it's a shorter book. And I feel like I'm getting somewhere. My problem is I go to sleep and I can't remember what I read the night before. So, you remember that movie called Groundhog Day?
Yes.
Repeating the same day in and day out. I feel a bit like Bill Murray. I keep reading the same pages, trying to remember them for the next day. Okay, I asked you last night to try some of these problems. I've given you a couple that are new. Did you try a problem that you looked at and said, I don't know where to go?
I didn't. I had to use the answers to figure out where to start.
Okay, but is there a typical one to look at that you now haven't tried that you look at and say, I don't know where to start? Or with what I've said, can you go through and make a decision, where do I start? So I'll leave questions up to you. Do you have any problem you looked at and tried and had a question in your mind, I don't know where to start?
Well, no. It's so when it says how many dollars will 2 quarts cost, you always start with dollars.
Okay, the question that Teresa's asking, if it says, how much does 2 quarts cost? So let me go to 67, right across the page. And here is the last part of the question. How many dollars will 2 quarts cost? What was the how many related to? Dollars. So we start with, on the top, $1 over?
2 quarts?
Well, that's a question. We have 2 gallons for $5. Doesn't that give you a fraction you can start on if you want dollars at the end?
So $5.
$5 over 2 gallons is my start. And that's as much as I'll say on the solution. Okay, other problems. Adrian. Number 8. Yeah, this was a wrinkle I threw in this problem just to be malicious. Okay, this is a problem. This intrigued me because tea is sold in tea bags, correct? Now, we talked about this problem. I asked Jeff how much in the restaurant they were selling coffee. I think we said $1.50, right? So this is 75 cents for a tea bag. So let's say that you are at maybe the student center, and I don't know if they're charging you 75 cents for a tea bag, but how much tea is in that little bag? And usually it's even less than a ½ ounce. But let's say they've been generous and give you a ½ ounce of tea. So the question is, in this problem, how many dollars will 1 pound cost? And so Adrian's question is, what do I do with that silly 1/2?
Make it 0.5.
Yes, I would make it 0.5. That's probably the simplest way. Or if you do have a 1/2 in the denominator, you can invert and multiply. But maybe just writing it as a decimal as 0.5 would be the simplest thing there. So I think that's the question in that problem. Where would you start? Since you want dollars at the end, let's come back to the problem. It says how many dollars. I'll slide it over just a little bit. The fact that I want how many dollars says I should start with $1, and I'd put that over what? 100 cents. Because I've been given what else in the problem? That's 75 cents for that ½ ounce. So first I would start with $1 over 100 cents, then the 75 cents over 0.5 ounces. Well, then you have to keep going. I won't tell you the rest. You can fill in the blank. Okay, he's trying to milk the solution out of this problem. And with tea, that's an English version. Okay, with milk and the tea, you didn't. Okay, going on. Okay, is there another problem you want to look at? Or I just start creating more problems for the fun of it. It looks like we are back to creating problems. Let's take a look at the supplementary set because I expect you to be able to do those. So that's all the way back on page 78 and 79. This is a problem that I enjoy looking at because we talked about this. Raising money for schools, these are activities that they send young, innocent children out to raise money for programs. So this is a school, and so the idea is you pay 1 cent for every yard she jogs in 1 week. Now the girl jogs 1 mile every day, and how many dollars have you committed to? That's the idea. Now oftentimes a problem like this, you look at the child and you think, not, wait a minute. Okay, Teresa made an uncomplimentary comment. The child might be a pain. Well, this young child, very delightful young child, comes to your door and says, will you pay this? It's so little, 1 cent for 1 yard. A penny? Not going to cause you any trouble whatsoever. And I'm only going to go to school 1 mile, and it sounds so innocent. How many dollars do you owe in 1 week?
Start with dollars.
Okay, so that's the question. Let's come back to the problem. So how many dollars? So I'm going to go to another board and clean up some material there. I'll go to the far left over here, Debbie. And I've managed to do photos of this, so I'll get rid of this. And we'll see what we can do here. Oftentimes you look at these young children when they're asking money and they are doing physical activity, and you think this child won't be able to do that much running. And you'd be amazed what they can do. Okay, let's see. We want dollars, right? So we're going to start with dollars. $1. The dollar store. And it was what? We had in the problem, she gets 1 cent per yard. Is that correct? So we're going to put $1 over 100 cents. Now the minute I do that, what must be in the next fraction? Cents in the top. I could say that makes sense. Okay. The cents will cancel. Now, coming back to the problem for a moment, Debbie. I can't see the part there, and I wish I could have Debbie just move to the right. We don't have that ability. But I think it was 1 cent per yard. Is that agreed? Yeah. So 1 cent in 1 yard. Now the cents cancel, but now you're going to have to go back to the table of equivalents. Because she's doing a mile, right, per day? And so we need to know something about yards and miles. So what do you find on that page? 1,760 yards. This is, I assume, an equivalence that you don't know, typically. Okay, so we can cancel the yards. But what does that tell me that I now must have as I keep going? I'm going to have miles, correct? That is self-guiding. How many of you been to the big trees? 5 of us? The big trees up around Arnold, in honor for you, Jeff. Up around Arnold, up in your Angels Camp area? The big trees? Okay, we got a few of us. Have you ever been to any forest where we have a guided tour and you walk around and they have you a little pamphlet, tree number 1, tree number 2, and this is the 3rd thing you look at? This is the guided tour. Because if this is miles here, you must have what? Miles here. Well, that's the question. What do I have in the problem? She does 1 mile in a what? In a day. Okay. 1 day. Well, continuing. We'll just keep erasing and this problem may go forever. Okay, the miles are out. Now, what else do I know? How long does she do this? Let's come back and look at if we got anything in the... She jogs in 1 week. So back to here. I know that the next one has to have days. 7 days in 1 week. And then times the 1 week over 1. Okay, have we had enough fun? Okay, you're being sarcastic. I caught that. There was no integrity to that, no sincerity. Let's slide all the way over. Now you're going to try to get out of it, Teresa. So I have dollars here at the end. Now we're going to do the number bit. 1 and a 1 and a 1760. And I'll just do the looking, even though people can't see it watching at home. There's a 7 and a 1. Those were all the numbers in the numerator. In the denominator, you can see the 100, the 1, the 1, the 1, the 1, and the 1. As I say, you've got to love the ones. And this is going to be what at the end? It's dollars. Okay, what can I do? I can multiply. Okay, so Adrian, who drives 90 miles an hour, has found an easy way to get through this problem. He's going to multiply 7 times 1760 and divide by 100 because that just moves the decimal 2 places to the left. Or you could say 10 goes into here 176 and 10 goes into here 10. So now that means you only move the decimal 1 place to the left. But for those of you who have your calculators, would you be kind enough to tell me how many dollars we are going to give to this noble cause? How much? Oh, no, wait a minute. I like Adrian's number better, Lewis. He says $12 and you're saying 120. One of you is going to make me feel bad. Lee. Which is it? Is it Adrian's 12 or Lewis's 120 plus?
It's $123.
I've got a second one for 123. Do I hear a third? We'll auction it off. We're at 3. Do I hear 4? Going. Do I need a fourth one? A fourth one. It's gone. 100 and what, Lewis? 123? And 20. $123.20. Take out that checkbook. And you thought you were just going to be at maybe, see, Adrian was hoping for just a $10 bill. Now, by the way, when somebody comes up and asks you, I warn you, you're probably better off giving a $10 bill. Flat rate. You get $10. That's it. And it takes the excitement out of it, but it saves your wallet. Okay, $123 is a lot of money to be paying out. I do this as a public service announcement. This problem is to make sure that you do not go bankrupt when that innocent child says, will you please? It's only a penny. 1 penny. You'll never miss it. Okay, let's go back to the problem in the document, Cam. Such innocent numbers, such big payoffs. Okay, is there another one that you want to look at? We have just time enough to maybe do a setup for one more. How would we set up one more? Do you have any choice? If you don't, I can quickly pick one. Number 3. Since we started talking about finals, this seems reasonable. I started talking about finals. If you decide to study, this is a choice you make. If you don't, you die. But going ahead, if you study for a final, an exam, and you want to do 30 problems. Now, I've suggested not 30, but what? 100 some. But let's say you do 30 problems, and each problem takes 12 minutes. The question is, so you understand it, you're going to do 30 problems, each problem takes 12 minutes. Then the question is, as I slide over, how many hours? So oh, that's good. The question was earlier, how do I know where to start? And it sounds like we found the answer. Okay, so as we look at this and come to the sideboard, the question here is, how many hours? So that is where you start. So first fraction, we're going to have an hour in it. Well, we don't know if it's 1 hour. Let's come back to the problem. Because in the problem, don't I have, and I can't see what's there, but what did it say? That you did so many minutes per problem, is that right? 12 minutes for a problem? So if that's what it tells me, then indeed I want this equivalent. 1 hour over 60 minutes. Then what must be in the next fraction? No, in the numerator. It has to be minutes. And then what was the phrase that my good friend Daryl Top used? Let the good times roll. Because at this point, you know you're going to have minutes up here, and you know that 12 minutes was one problem. But that tells you that the next one has to be what? Problems. And you were going to do how many of them? 30. You're done. And then it's just a matter of carrying it through. Okay? And notice, I rigged this for you. Do you notice how nice this one is? Do you appreciate that? Do you get goosebumps? There's a sort of a sarcasm that comes out. Oh, your voice, the bronchitis is saying that I shouldn't be critical of the fact that it didn't sound sincere, insincerity, because the kindness was here. Yes? And then the 2. And so you only have to study 6 hours.
That's still not very kind. 6 hours is a long time.
But 6 hours is,
Break it down into 3 days.
There you
yeah,
go.
spread over 3 days. There you go. And Adrian says, and you won't remember the first day. This group has an answer for everything this morning.